Ladies and gentlemen, welcome to section 12.5 simulations. Now here we go, ladies and gentlemen, with some vocab words right away. Theoretical probability. That is what should occur in a probability experiment. So if we are flipping a coin, that would be an experiment. Theoretically, it should be 50% heads, 50% tails. Or if we're rolling a dice that has sides 1 through 6, they should each side should occur 1/6 of that whole time. Experimental probability is what actually occurs, because if I flip a coin 10 times, will 5 land on heads and 5 land on tails? Not necessarily. I might end up with 7 heads, 3 tails, or I might end up with 3 heads and 7 tails. And then relative frequency is just the number of times an outcome occurred in a probability experiment when we actually perform that experiment. So let's take a look at some. Here in our experiment, this would be the experiment, a die, which is a dice with how many sides? 6 sides, is rolled 50 times, and these results occur. So we are asked to find the experimental probability of rolling a 5. Well, here is the outcome, the 5. It happened 6 times. Well, 6 times out of how the total. So it's 6 divided by 50 for our probability. 6 divided by 50 simplifies into 3/25. And for right now, ladies and gentlemen, just leave it as a fraction. You can also represent probability as a percent, but we're going to leave it as a fraction. Next, we are asked to find the experimental probability of rolling at least a 5. How does that at least a 5? What's that do to the question? Well, at least a 5, we want a 5 or greater than. So we want a 5 or more than a 5. Well, our frequency for a 5 is 6, and what if we roll a 6? That's going to be 7. So the total number of rolling at least a 5 is 13. Well, 13 out of a total of 50 would be our final answer. And then we are asked to find the experimental probability of rolling a prime number. Well, what is a prime number? A prime number is a number that only can be multiplied by 1 and itself. It has no other factors. So a prime number would be 1, that's prime. 2 is also prime. You don't think of it as being prime, but it is prime because 2 times 1 are the only factors of 2. 3 is also prime. 4 has 2 and 2, so that's not prime. 5 is prime, and 6 is not prime. So the frequencies we have to add up of all our prime numbers. So that's going to be 6 plus 10 plus 14 plus 6. We add those up to be 36. Well, they add up to 36. We put that over 50. Please simplify your fractions. So that turns into 18/25 for our experimental probability. So when we perform the experiment, it happened 18 out of 25 times. Again, the frequency is the amount of times it happened. Some more vocab words. A simulation is using an object to act out an event that would be difficult or impractical to perform. And then we have a probability model. And all that is a mathematical model used to represent the outcomes of an experiment. So let's dive more into these vocab words. With an example, here we have Mandy is a pitcher on her high school softball team. Last season, 70% of her pitches were strikes. Design a simulation that can be used to estimate the probability of Mandy's next pitch is a strike. Well, it's not very applicable to just go have Mandy pitch 100 pitches and see how many are strikes. We can design an experiment for that. Well, what kind of an experiment should we design? You can put random numbers, 1 through 10. 1 through 10, those numbers where 1 through 7 should be strikes, because that would be 70%. And then let's say 8 through 10 were balls or not strikes, and that would be 30%. And you could pick those numbers out of a hat, out of a bucket, and that would be our probability model where we represent strikes are 1 through 7, balls are 8 through 10. Now there's different models that you could use. You could use a 10-sided dice. You could use the alphabet, 10 letters of the alphabet, where A through the 7th letter is strikes, and then X, Y, and Z are all balls. So there's different ways to represent simulations using different probability models. But ladies and gentlemen, that does it for section 12.5, simulations. Good day.